Okay, this is number 3 video and chapter 6.3, 6-3 and assignment 31. Okay, it is about the normal approximation to the binomial. Okay, some survey shows that the fewer people enjoy shopping than in the past. Survey asked a nationwide random sample of 2,500 adults if they agree or disagree that if they like buying new clothes, but shopping is often frustrating and time-consuming. The population that the poll wants to draw a conclusion about is all U.S. residents aged 18 and over. Okay, the problem is here. Suppose that exactly 60% of all adult U.S. residents would say agree if asked the same question, that X the number in the sample who agrees. Okay, so it's we have to, that's assumption. Okay, show that X is approximately binomial random variable. So if we consider if this is a binomial random variables, we have to go through this bins, B-I-N-S. The first one is possible outcomes each trial can be classified success or failure. So success is finding, when we asked the question, they answered 60% adults said agree for what? The shopping is often frustrating and time consuming, okay? I like buying new clothes, but shopping is often frustrating and time consuming. So that's the agreement sentence. Okay, now, let's see. Independent or not. So 25 adults. So if we find one adult who agreed, right? Next chance will be slightly off because we found one already. So next adults will be 2,499 adults. And it's going to be less than, little bit less than 60% because we already found one, okay? And if we find two, it's going to be less again. So actually, it's not independent. However, what's the rule about if it's a big, large number like this? Let's go back to the video. If you didn't watch the video, please watch the video. I think from this this one, the flash drive video. Okay. I talked about 10% condition, which is N has to be less than 10% of the population, less than or equal to. So what are they targeting? What's the population they're targeting? Let's read this one. Problem, suppose that exactly 60% of all adults in USA. So compared to 2,500, it's much less than US population. It's much less than 1/10 of the US, 10% of US population, right? So this is independent, okay? Even though it's not independent, it's independent enough because the 10% condition is met, okay? So that's number 2, okay? All right, so numbers of a trial. So again, 2,500, success, 60%. Okay, now that's letter A. Check the condition of using a normal approximatory in this setting. Okay. What was the condition? So that was about the airline company, that to find the captain rule. So we couldn't do, we couldn't come up we couldn't use the binomial probability setting, this one, because we didn't have enough population yet. Now, what was the rule about population? N times P. As a rule of thumb, we will use normal approximation when N is so large that N times P has to be bigger than 10. N times failure, it has to be bigger than 10. Okay, so let's see. 2,500, so let me open the calculator. 2,500 times 60% is bigger than 10, okay? Failure is 2,500 times 0.4. Again, bigger than 10, so this condition is met, okay? All right, use the normal distribution to estimate the probability that 1,520 or more sample agree, okay? So that's why I got the normal model here. How do you get expected value, which is mean, right? We can use the letter mu maybe, if I have mu here. Population, we can use mu, right? So, oh, population, it's not population, it's a sample. So I will use, let's see, let me check the answer key, what they use for mean. Oh, they just put the number. Okay, so let's put the number. But this is mean, okay? We cannot say mu because it's not the population, okay? So it must be x bar, right? So this is, oh, they use mu here. I don't want you to get confused. So they didn't define, so I use mu for this one because it's approximation to normal. So we assume that is kind of, you treat like a population, not so much of sample. So that's why I can use mu. Okay. Now we cheated. I look at the 1,500. So let's see if this is mu is 1,500. How do you get the mu? Right here, n times p, which is 2,500. Oh, this right here. Okay. Times 60%. So this is mu is 1,500. So now standard deviation is square root of n times p times failure, 1 minus p. So let's see. Put square root sign. N is, what was it? 2,500, right? 2,500 times success rate of 0.6 and failure rate was 40%. 2450. Okay, so 2450. So I wonder if you remember the z-score from here to here is 2450. I wonder, I put 24. Let me see your answer key. 2449. So a cutoff line is 2 decimal, hundreds, nearest hundreds, right? So this time, oh, good. So they use mu here. They use sigma here. Okay, 2449. So let me put this on here. Even though it's sampling, they use kind of sample survey, they use mu. So I don't want you to get confused later. So this is the equation. And this is my TI calculator equation too. So one standard deviation above is 15, so I will put a little bit estimate, 1524. Okay. Now, it's supposed to be little, it's only the, if this is right here, I would change the color to the green. Green dotted line is one standard deviation above, one z-score above, all right? But so 1520 should be a little bit low. I'm sorry, this one should be low, not move. So I will lock this. This should be lower. And how many people, what does this say? Will agree. So agree is, wait, going this way or this way? 60% is agreeing. So distribution from here to here is success. Okay, so I highlight this. So how do you get this one? The probability. Right? Okay. So let's see. Let's see how, oh, the other way around. Let me see, double check. Upward binary distribution, more success. Success. Let's see. From the farm, so we did this, and we got the z-score. We didn't get the z-score, but it's a little bit below 1. Should work. Okay, so let's see. Why highlight it that way? The definition of success is here, right? Mu. Oh, I'm sorry. Yeah, 15, 20, and more. That's why I just, I'm sorry, it's a little bit stupid on me. I didn't read right. Okay. How many people agree? 1,500 and more agree is going to be this distribution here. Sky blue. Okay, not the yellow one. Okay. And I should not highlight this. It's confusing. Everybody is going to be what is, so use the normal distribution to estimate the probability of 1,500, 1,520 and more, okay? So how do you use the calculator? So now, this is a normal model, right? So it's going to be, you can go to second bar and normal CDF, okay? This is negative infinity, but we have to go to positive infinity that way. So the cutoff line is 1,524. I'm sorry, 1,520. 1,524 was the one standard deviation above. So if you want to run the z-score, you can do that too. But I would type 1520. And upper one is 1 times E, natural number, to 99 power. That's how we used to do it. I forgot. 99 close. Mu is 1,500. This is not something I remember. or 1E, I'm sorry, 1E. That was slightly different of that I saw. Oh, this one, sorry. Yeah, I remember. 1 times highlight EE to just like this, right? You might not need this multiplication number. Okay, now standard deviation is right here, 24.49. Okay, let's paste. Okay, I got 20%, 20.7%. Let's see. Got the if you run the Discord, this is the way. But you got the similar one. So this is the way, 20.71%. Okay, so this is it. So if the conclusion is there is about 21% of chance of getting sample in which 15, 20 and over or more agree to the statement. I hope you understand. And this is weekend music for you. I might make more video for you for the test review. I didn't finish 6-3 yet because there's a geometric probability we have to run too. But if anybody's watching, maybe can do. I noticed we can't cover the chart that much. So.